Well, folks, all right. As I promised you last week when we met, this week, the class is going to be virtual, right? So I'm going to post this recorded videos, and then you go through the process listening to the video. So you'll be able to complete the week task, right? I mean, the assignment and the quizzes that may come this week. As I promised, I'll be away for a conference whole week in California. So uh, that is why we are skipping in-person class this week. All right, with that said, we're going to go over our week business, right? Today's discussion is going to be about typical everything related to your concrete work, right? Again, in this class, we are supervisors on the job site, being superintendent or project engineer. So what is our core duties over here when it comes to concrete work? We are looking at what you need to know to properly oversee every related item to a concrete work. So that is our business for the week. And in doing so, we need to know all these elements listed here. At least we should have understanding on how these items work in relation to how you're going to be placing these on the job site, making sure your team goes about execute the work diligently in accordance with your project manual. So that is our concern for this class. So what is formwork types and how it is being done or executed? How do you construct a formwork to be able to get your concrete poured on the job site? What about materials for that? Right? Why is concrete items group per your master format, which is division 3, item C? What do you need to know based on this master format, and how would that help you organize your concrete work items on the job site so that you and your crew will be safe enough, confident enough to be able to finish that project related to everything concrete. Testing of your concrete. How does that matter, right? Why do you need to test? For what? We should be able to understand that so that we can make sure our crew on site knows the strength of the concrete that they are working with. So it's important. Why do we have to create joints when we are pouring concrete? What are they for and all that? So these are the things you need to know to be able to properly oversee concrete work items on any project that you're part of, or you being a supervisor, or sit between your superintendent and the project manager as a project engineer, and so on. So keep that in mind before we start delving into details on these related items you need to understand or know so that you can do a diligent supervision on the job site. All right, before we go on, the statement here is clear and concise, right? Concrete is the number one most commonly used material because it is what? Most versatile building material. What does that mean? It can be adapted to any shape on the job site. You can define the concrete in any direction or shape that you want in your project. Based on that, we can safely say it's the most versatile building material. And as we go through the discussion, you will understand why most projects that you have been part of before or you've seen around you mostly have concrete elements in there. All right. Beautiful. Let's go. Why is it so a versatile material? These are my reasons as listed here. Very durable enough to be able to support itself in terms of weight and carry other weight enough, right? It's very resistant to wear and tear, and that is important. It's very fire resistant. When fire get in contact with the concrete, it doesn't burn off quickly as wood or ash or foam or whatever it may be, other materials, plastic and so on. So it can resist fire for a longer time before destruction finally occur. You can mold that into different shape, making it so versatile. What about it's a natural insulator as well, prevent can be used as insulation, right? To sit between the exterior environment and then internal. So very good, low maintenance. When you use concrete, you don't do that maintenance quite often as wood or plastic or PVC pipes and stuff may be undergone. So those are key stuff. And it is eco-friendly or environmental friendly here that concrete can be broken down and reused for different purposes. So it makes the environment friendly because you don't throw the waste away to cause pollution and so on and so forth. Most important in here, very cheap to hold. It's cheap, right? You can have it anywhere. You can mix it right from where you want to place it, and so on. So these qualities make it versatile in terms of environmental friendliness, right? It doesn't cause all that volatile organic compounds that may cause pollution to the surroundings of where these materials use. So in clearing this, reasons why you have concrete in most projects because it is versatile in terms of being able to being adjust to all the list that I just talked about. So keep that in mind. I talked about concrete being organized in your master format, CSI master format, which is division 3. Every item in concrete for your project can be found in that division 3. If you have taken the estimating class already, this is the starting point to be able to start aggregating your materials or do your work breakdown structure to be able to estimate, do your quantity takeoff and group type of concrete under your master format CSI division. All right, what does that mean? It tells you that concrete are grouped here, as you can see, all the forms, concrete form, forming, and accessories. When you look at that under division 3, everything related here is under form, right? You can have a form work for your stairs, permanent, temporary for cast in place, concrete, liners, and so on. This is your first step in the division 3. And then you can have all the accessories and then water stops and so on and so forth. So with this, you know exactly that the sequence on which you can group your concrete element so that you prepare a proper way of doing the supervision on site, right? Think about your reinforcement, right? Concrete reinforcement, you have the steel bar rebars and welded mesh and so on, pre-stressing tendons and all that. So under this, you know where these elements under your concrete reinforcement falls under division 3 and how you're going to be preparing to be able to make sure you supervise and placing reinforcement adequately and where it's supposed to be on that job that you supervise or being part of. All right. Let's move on to the next point will be your cast in place concrete. This is the concrete that you're going to be pouring right on the job site where you need, right? So you're pouring columns, beams, grade beams, footings, and so on. Your foundation concrete and all of that. So under your cast in place, you would do all the structural elements, the architectural stuff, which is the mass concrete in the low density areas that you need to, and then finish concrete. So you group all this so you can assign proper skill, labor, and on-skill to be able to execute this job. And again, it will also help you to determine the labor rate for each of this based on the division they fall to and the severity of the work that is going to be done in each of these sessions. All right. And then the opposite side of it will be your precast concrete, where you have a yard somewhere that you cast this concrete dry enough and transfer them to the job site and place it, right? So you can have a architectural concrete that are precast. You can have site concrete that are tilt up. We'll talk about them, then lift slab and so on. Some of them you can prepare a yard on the job site, cast it, make it dry somewhere, and then lift it to the place that you want it to be on the site. So think about all these differences. As we go through the list, think about how are we going to do this. I'm referring to the methods and the sequence in which these work items has to be performed on the job site. It is very important. If you looked at it from that angle, then you have a clear picture as a supervisor. Who are the team that I need and who is to support what and at what process do I need A, B, or C to be on site for this specific work? That is our uh, thought process here. All right, so you can see the screen right here. We are looking at the components, right, that are constructed with concrete, right? Typical construction project that you may be leading, which are constructed with concrete. We start with the concrete piles, referring to the picture you see here. All those columns, your floor slabs, your wall footings, your spread footings, and all the columns, the beams, the joists, and the spiral beam, different types of beam, are all part of component that forms or comes together to be your concrete element of items or concrete items. So if you see the list here, we come all the way from concrete pile, as you can see here, to the footings, slab on grade, all the way to airport runways, right? All these things are concrete elements that are part of most construction project, right? The way you construct the method of construction for airport runways is different from how you're going to do your slab on grade. This is what you need to know. So there's no one fixed method for all the elements here. Every element based on where they fit in the project, the location of it will determine how you will be supervising and come out with a method of construction as well. All right. So think about that. Let's talk about different foundation concrete, right? We will start with the shallow concrete foundation. Why are we shallow? We're talking about some concrete that you won't dig so deep. Yeah. So which type of project call for those shallow concrete foundation? If you can see the list here, we have the straight footing. We'll be going through what are they. This is the list. Just take a look at it. We have a grade beam footing and so on. Where do we need it? And why shallow, right? Let's look at them one after the other, right? We talked about the strip, or the wall footings. Where do we need it, right? Use where the bearing capacity of your soil is adequate for the load being transferred, right? So in your residential home, as you can see that it doesn't have to be a very deep foundation. We are saying that this foundation we see here can support all the load of this residential home. So in that case, you won't dig. So see the width or the depth to which you need to excavate this foundation, right? 9 inches, straightforward, not even a foot, right? So with this and then reinforcement or rebars and the rich concrete type that you have, you will be able to use strip to support the residential building we have here on the screen. So it is shallow because we are digging only 9 inches, right, by 20 right here to sort of support the foundation to carry this whole residential building. So with that, a project like this, you don't need to do a deep foundation, but it's going to be shallow. Talk about spread, pad, or column foundation. What does that mean? So this is what we are talking about here. This is a spread or a column or pad foundation, right? The idea is that it takes the load to a specific point, right? That is a concentrated area, and then spread them onto the soil or the earth. So that is what is so you design your column in such a way that your foundation in such a way that this column will transfer this to that specific point, as you can see here, and then from that point it can spread it. So we have a point load. uh, those my civil guys in the class, you're calculating the load and weight of the foundation, how it can support itself, and every other additional load that may come. So you can do a point load foundation or column footing that you get the load transfer straight to a specific point within the foundation, and then they spread it. And that is very important. Think about slab on grade. This is very, very shallow type of foundation. You see all that here. All that you need is to cut that 6 foot thickness slab on grade to carry that fairly light building here. So you just cast the uh, slab on grade, reinforce it, and then you'll be able to put your very shallow residential one-story building on it for you. It doesn't have that much load, except the roof here. And then you have a crawl space. You look at that space, sometimes your basement may be somewhere there, no fully basement, but you don't have that space. It's just a little crawl space over there. So you need to determine what type of foundation here and then what type of foundation to be able to support the load that is coming from that end. All right, so it's a basement foundation. Sometimes all concrete before you get to the slab on grade for your first floor if it is 2 story or more, and then if it's a residential home 1 story, you just have to do your slab on grade here and then make sure your crawl area has adequate support to carry this load. Let's talk about the raft or the mat foundation. It looks like the slab on grade, but here you have an adequate space or width here with those raft columns on it, right? So you look at that, that's a mat all over, as you can see, and then it will support your, this is the mat that is stabilizing the the soil So this is alternative to the closely spaced and isolated column, like the crow area. And then the bearing capacity of the soil is low. If we have the soil here a bit loose or made up ground, you will introduce the mud and cast your column or concrete on it to make sure the soil is more stabilized to support the load that is coming on it. All right. And then one of the shallow concrete foundation will be your grade beam. Very important concept here. You have your grade beam running through the the piles, the two pile caps or under the pile, so you have your pile foundation here and then pile foundation there. You cast the cap, alongside the grade beam, right? You put it, sorry, you put the grade beam, yeah, right there, and then cast it over so that it will be able to support this wall. Because we may have, so the grade beam more or less will be your concrete, foundation concrete, let's put it that way, right? So you have the it typically span uh, between the footings. So the footings here span between that and transmit the weight above the directly on the footing, right? So why the wall footings transmit that? So that is very important. Again, all these types will be found in your project manual, which is the drawings that you're using. And then your specification side will determine how you're going to be constructing this element and make sure they meet the code requirement. Building code, right? Let's talk about formwork. What is formwork? Why do we need that in a project that has a lot of concrete work in? We need a formwork to make shapes the way you want the concrete to look like. If we have a column like that, definitely your formwork should be in this shape to mimic the column types or beam types or slab types we have in those projects. And there can be different materials that are used for formwork. The most common one we use for simple project will be your plywood. You cut it with your other wooden members and form the shape that you want. We have a steel plate, steel beam. Oh, so all these materials can be used for your formwork construction. And then that will help us pour the concrete to the shape that we want. Types of formworks that mostly are used for the project. Whatever form or type that you use as listed here, a job built formwork here means you're building your formwork in place because you're going to cast concrete in place, right? You're going to pour the concrete right there. So you will do that. You can have a modular form that is prefab somewhere and bring to the job site. You have the gang, which will be looking at these different types. We have table or fly-in forms. We have a climbing forms and so on. No, whatever types that you use, you make sure that they meet this function. The formwork must be produced, that must produce the required surface finish, depending on where the form is. If you're not going to do painting and all that, it has to be smooth inside finish to the point that when you strike it, it gives you that surface that you don't need to do anything with the concrete surface again. It must be tight enough to avoid leaking. When you're building the formwork, it has to be watertight because you're going to be using the cement and water ratio, whatever. So if it start dripping, you won't get the required strength you're looking for. And then it should be strong enough to temporarily support the concrete weight, right? So these are things you need to look at when you're building that formwork on job site or supervising it on the job site. Make sure it is built to be able to support heat weight, right? Produce a good finish so that you don't work on the concrete so much in terms of finishing, and then avoid the formwork being leaking around, right? So that is very important. I talked about different types, so these pictures here illustrate those different types of formworks that I talked about. Think about the gun forms, you know, the individual component here that are built with the modular. So this can be moved in place based on where you need them, right? And then the modular forms are right like that, can build in a different application, and then you can reuse this in different projects, right? Very important. Think about the table. Simply means it's supporting one slab. So this is cast already cured enough, and then you build your table form here to support the other slab that you're going to be casting over here. And then we have a slip form mostly for the tower construction. So this has a jack hammer or hydraulic mechanism system that will push this form up as you cast it until you get to that point and finish it off. So different types of formwork with a different types of work, depending on which type of work that you found in your project. You can go with a jump or climb form. Here, you're going to hook that to an existing concrete, right? And then after that, you'll be able to pour the concrete here. You see, this is hook here, and then you're going to be pouring your concrete to those different spaces, right? So those are the simple way that you can uh, go about to cast your formwork. And then you have a slip form mostly for horizontal project, or like a road curves and gutters and all that slab that you need to carve with the median and so on. So you need to do that. So as it goes, you pour the concrete, you pour your slip, and then move along. All right. So I hope you guys are clear up to this point. Like I said, because we are not meeting in person today or this week, you send me emails when I have time. I will reply them to you after watching this video. And you have other concerns, don't hesitate to do so. Reach out before you start the week exercises, right? So let's look at the method of formwork construction. What methods do you go through to be able to erect that formwork here with, with that? Of course, you need those guys to help. So you deal with your fabrication first, fabricate your formwork or build a formwork in place. This is building that in place, and then you can fabricate it somewhere else and bring it. You need to oil the inner faces of that formwork. So oil the surface of the formwork so that striking it after the concrete is cured become easy, right? And then do a layout and stake. That is exactly what they are doing here. They are laying out and staking the formwork so that it take the shape, the level, and the form of the concrete column that is coming on there. If you feel the grading and staking point, you're going to have a column that looks like that, right? Right? Tilt. Meanwhile, you want it straight. So you don't want to have a 3940 shape of column. So do the layout and staking very well. And then whenever you're done it, making sure you're okay, you do your placing and assemble the formwork in place. And then after the concrete is cured, you strip and remove based on the oil surfaces that you have inside the formwork. It's easy to strike it, possibly reuse it somewhere else in the project. Let's talk about formwork and forcework. Always we use formwork, but the difference here is simple. The forcework is for those my friends in the heavy civil highway project. You're constructing the bridge, the deck, and also shoring the edges of that road that you did cut and fill. You need to show the surfaces of it. You need to create a force work. But mostly we term all of it as a form work because form work is commonly used in a vertical construction project, right? So force work materials similar to form work. Same. You have steel props or posts, you have steel shores, you are bracing all the way to bearing plate, sun jogs, and so on and so forth. How is this material used in putting together the shore work or the force work on the job site? As you can see here, very simple. The pictures illustrate everything like easy. So the steel pipes and the beam for the force work, this is the bridge supporting this bridge. So these are the steel pipe and the beam to support that. What about the steel beam? Uh, Hank for the force work. You see that this is a steel beam. We are casting the beam here, so we're going to be using that for the purpose. And then the shore and the reassuring for building floor, as you can see, this shore force work supporting the deck, right, of the slab that we are going to be casting. So this maps up to that, right? So again, in the job site, I have always see my guys talking about form work, I mean, using the same for roads and buildings. So if you hear that, don't question anybody or fight with them on the job site. It's the same. It serves the same purpose. Okay, right, good. Right. So force work method of construction here, very simple. If you're building a force work for this project, you need to fabricate the individual force work members, the pipes, the stack, and the bracings, and so on. The layout and staking part is most important, right? It will define the levels and the shape of this project. So make sure the stake out or layout and stake for the line and grade are very important. When you get it right, it is easy to place and frame your force work system. And then after your concrete is properly cured, you can strike it. So very important. This is a very important areas, right? Placing of your rebars, reinforcement material. Every project that you have been part of, you will see this rebars everywhere. So far as we have concrete work in there. What is your role here is to make sure these bars more or less place well. You work with the steel benders and those guys out there to make sure the bends and turns that are found in your drawings are done properly. And kind of form those rebars, and then pouring the concrete is important, right? So you can have different rebars specified in your project documents, especially the rebar schedule for your concrete work. You can have uncoated steel bars. Where do you need them? Your specification will tell you uh, at the edge of your columns and beams needs to be uncoated steel bars bent at 180 degrees to be able to secure the edges and peripheries of your concrete slab, right? So this will really tell you what you need to do. You can have a welded wire fabric and so on and so forth. Again, these types will be clearly stated in the first page of your reinforcement bars drawing in the in your project, and then you go to the specification, the sections that deal with reinforcement, will tell you the method of construction. It is very important to get it right for the strength and safety of your project, right? Let's talk about how do we determine these bars and standards in our drawings. So if we are using US standard, which is ASTM, right here standard for you, how do you determine the inches or the inches take, how many inches take is the diameter, number 4 rebars and number 8 rebars, right? So we are seeing number 4, number 3 rebars all the way to 18 here for ASTM, your standard. And then that's ASTM is American Society for Testing Materials and Bar Sequence. All right. So you see here, it tells you the main rod, and then the H here define the letter for the placing mill right there. So every letter here means something. So keep an eye on those grade type of materials for the rebars. So let's come back to our question. How do you determine the diameter in terms of inch thickness for your ASTM? We have number 4 in the question. How do you determine its thickness? You divide this by 8, right? So 4 by 8 will tell you your diameter in inch here, which is going to be 0.500, so 0.5 for you. So that will tell you the thickness in terms of the diameter of your bar here, right? Right. That's what we are looking at, right? The same thing when you pick the number 8 bar, you divide this number 8 by 8, right? And then that will tell you your number 8 bar has a 1-inch diameter for you, right? And this is what you will need to be able to adjust your pricing for purchasing those rebars, right? I hope that makes sense over there. In your typical construction drawing, this will be your reinforcement material and the bar bending schedule. So you go to site, most of the guys will talk about bending schedule for rebars and so on and so forth. This is how it looks like. It tells you different bending and type of rebars and materials that we have on the job site. If you look at here, the hook details. It tell you how your bending details are. Diameter, 180 degrees over there. You can bend 90 degrees, and then it comes here as your bending schedule. So look at the bar sizes running here, and then you have all the diameters associated with it. And then A or G means these diameter here. What is the length of this bend, right? You can see all that listed here, and then different types of bends. So this is what you look at and check the framing of or molding of the rebars, and then that you'll be able to determine. So keep an eye on the numbers in here and see the legend, what they represent. C will be your pitch, and then you have your overall height, which is B for the bend, and then you have the number and all that. So this is how you start reading your bending schedule to make sure it is being placed properly on that formwork that was built ready to pour the concrete. All right, reinforcement types and method of construction, right? We have a steel bar. You always need to deal with the shop drawings, which are ready to be fabricated and bring to site, or in place, fabricated them in place, or cut the main bars to the length, right? You look at your shop drawing. This is a typical shop drawings, right? And then you will cut every rebar to the required length and sizes, and then cut and stir up to the length. So every bends will be done from the main bars shape. For instance, let's go back. These are different shapes, so you need to bend your main bars to this different shape, as you can see here, already as a method of construction. So you bend the strip to the shape that is one, and then you place and tie your rebars. So let's go back to the drawing here. This is you place it. So each intersection here where the rebars meet, you use a tie bar to just tie it, making it secure, ready to hold that concrete. All right. So if you're using the pre-stressing approach, again, you need a shop drawing. Same thing. If they are going to go through a dart, you cut the dart and the anchor head so that it fit into that. You cut the pre-stressed steel, and then you're going to be pulling it through the dart to kind of strengthen the edges where the dart is going to be put. So the dart, your typical dart will be your HVAC stuff that you're passing through that HVAC conditioning, heating stuff into those spaces. So follow the process, and then you grout around the duct so that it fits in all the spaces, so you don't have much outside water coming through those spaces, right? So that is a typical method you will use to prepare your reinforcement or rebars for your project. Let's talk about concrete ingredients. After all, we are saying everything related to concrete. To get a concrete, you have a combination of stuff here, as you can see. First will be your coarse, aggregate the stones. So those of you who took the material lab class, you understand this clearly, right? You need your water admixture here, you need the cement, and then you need a fine aggregate, which is your sand. How do you proportionate this to get a usable concrete for your project? It is very important. So all these ingredients have to be put together so that you will have a workable concrete to support your project, right? Talked about admixture, you just want trapping air inside, right? And then you set a retardant into that to make sure you are aerating all the the curing process. And so you can do the coloring also by adding different mixtures to tan the color of your concrete and so on. All right. And then as you prepare your concrete work, we talked about accessories. These are the things that support the placing of concrete. If you're going to transition from the concrete to a steel columns, you need to introduce your anchors, right? The anchor bolts here bedded into the concrete so that you can bring those steel columns on. You can also use water stops just to make sure you get water drips away from the concrete. You can insert some whatever shape of whip hose or whatever in there to direct any water away from the concrete. All right, mix design. Again, if you did the material class, why do you do mixed design? To test the strength of the concrete. So we call this a slump test, right? You mix it, test the proportion of aggregates, ingredient that we saw, your cement, sand, and gravels, and make sure they mix together. They are not so watery enough or hard enough. So you mix and then test the design and make sure that is what you need for your project. This sheet is very important. I can spend the whole 1 hour explaining this, but I'm going to introduce that very quick for you. All right. Concrete mix design. This is your job. You are a supervisor on that job site. If you're ordering a concrete from a batch plant, you need this mix design to send to those guys so that they can bring you right concrete for your site. Mix code is important. Any batch plant, you send this to them as a supervisor or superintendent, you order the concrete by this code, and the inspectors can verify this concrete on the batch ticket, right? That is very important. So you send that code, hey, I'll be pouring concrete tomorrow morning, and this is my mix code. I need it on site at 11 a.m., ready to be poured. And then you get it, all right? Again, you need that number here. It tells you the name of the mix, but different from the mix code as well. Think about one more thing here, your design 3.5 maximum, right there. That tells you the slump test that is performed and then the required strength that you need for your concrete. Think about the weight, the unit weight of that concrete here, the weight of 1 cubic foot of your concrete, most designers may be adherent to. So the maze design is very important. If you start as a superintendent on the job site, you need this to guide your concrete ordering and so on. So look at here, you have the materials, and then you have the description of the concrete material type here. And then finally, you have specific quantity that are gravity that are needed and all that. You have all the blend percentages here, and then design quality that you expect for each of the concrete. Very important. I have a very good source here on the YouTube channel. You can go check that guy. He did a good job in explaining the design mix for you. All right, again, how do we calculate the concrete ingredient, the quantity of it? Mostly when you're given that equation here, you should be able to do a good job with it. The weight of ingredient in LP will be the volume multiplied by your SJ here, and then multiplied by your constant, and then that will determine the weight of that concrete. All right. So the example here, I have a scenario which details require 1 cubic yard of concrete for 27 cubic feet in volume, and then 6 sacks of cement is specified. 0.5 water given water cement ratio. The weight is 94 pounds, right? And then giving all those details, just take your time, go through the numbers here, and then you know where they're coming from in my calculation. So you will start with computing these different materials here up to 6. They are the mix for your concrete. You remember we talked about cement, water, air, fine aggregate, coarse aggregate, and then you'll be able to determine total volume in mix, and then total weight in mix. And then finally, you get the weight, unit weight of your concrete. So here, you will have your 564. Simply check here. It is 6 box that we have here by your 94 pounds, and that will give you that total weight for you. All right. So when you bring that here and put it in the volume calculation, it will be 564 divided by your numbers here, which we're going to be looking at, or are found in those because we have specific gravity 3.5, and then we have our 6.2 for the constant equation here, and that should give you the total cubic feet of concrete that we need, portion that we need for cement. If you pick water, we have the water cement ratio multiplied by the weight of the concrete, and then you're going to be dividing that by your 62.4. You should know the weight of the water or the volume of water to be added to that mix. What about the air? 0.05 here given here for you, sorry. So all the numbers are in there, and then you'll be able to arrive on your total unit weight for the concrete, which is pound per cubic feet. So that's a very straightforward exercise. You'll be meeting some of them in the quiz, so pay attention to it, right? All right. So let's deal with the concrete production method. How do we produce concrete? If you have lived in a village before, or countryside, or somewhere volunteer in Habitat for Humanity project, we do small concrete and then we will mix it by hand, right? Then we are done. All right. Again, think about hand mason. It's just a manual work. We talked about the batch plant, this guy here, this is where you send your design mix to, and then they will load this truck per the batch plant. We can do our own mixing, the drum mixing, in on our job site, but we need to follow the mix. And then we can do truck mixing whilst this truck is coming to your site. All the mixes are in there rotating. By the time it gets here, appropriate and the required proportion of water cement ratios done, and then this will come and just pour the concrete for you. So depends on the type of concrete work, severity of it, how large it is, you may go for one of these production systems. But here in North America, we do a lot with the batch plant and possibly a truck mixes, right? So think about that, how you're going to be supervising that. If you did the testing, or did I say the testing? If you did the materials class, you did a slump test. What does the slump test here means? You're going to be mixing your concrete, take your cone here, fill it up, pull it, and when it's like this, it means the mix is not really, it's a low slump, so it's kind of more water into that. You need something close to that. All right. And then after it is done, you're going to be subjecting this to the test, right? The air content test, the compression test on the materials lab. And then you see how this concrete will crack. It will tell you whether the formation was right or not. I'm sorry. Let's think about method of construction for a cast-in-place concrete, the ones that you're casting it on the job site. You prepare your formwork and pour your concrete right there on the job site. You need to pre-qualify your suppliers. Those batch plant guys, you need to make sure they are bringing you the quality. You qualify them so they are part of your supply that will bring you concrete. You get them down. You need to think about your RFQ, request for quotation for different suppliers that you qualify, and then whichever that makes sense to you, you select them to deliver the concrete, mix concrete to your site. You need to do try mix with them and make sure the mix meet all the requirement, and that is why your design mix play a key role here. It's going to, that code will help them mix the trial one. All of you are in agreement before they start supplying that. And then you're going to be pouring the concrete after you do the trial mix on the job site. And then you're going to be uh, you have a concrete pour plan, which is very important. How are you going to pour the concrete? How are you going to take the delivery? At which point and how long you're going to pour the concrete so that you don't get hardening while pouring. All right. So then you order your concrete based on the pour plan here, and then mix and produce concrete, right? And then you transport them. So this is a typical steps or sequence on which method that you base to deal with the cast in place concrete daily on your job site. All right. So follow this methods strictly to be able to get a very secure and quality concrete pour on your job site. As you pour the concrete, times you need to introduce this joint here for expansion and contraction. They are very important. And one of your schedules will determine concrete joints. At which point do you need to introduce joint and all that? If you see poured concrete started the cracks here, you need to saw cut it and create a joint in there, right? Think about those keys here, how the joints fit together before pouring them. All right, and then the opposite side of your cast in place is typically precast. This is cut somewhere else. Allow it to dry or cure enough before you bring them to site. Most component or type of areas in the construction that you can do a precast will be your walls, beams, columns, slabs, and studs. All of that you can cast it somewhere and then come and place it right on the job site. All right. Why is it important? Why will you go for precast as against the cast in place? Sometimes the space on that job site, if you're doing a downtown project, for instance, if you're Miami, Chicago, or Houston downtown, or Cincinnati downtown, the limited spaces. So you might want to cast this somewhere, make it dry, and then transport it to site as and when you need them. So tight space construction, you may resort to this type as well. And then sometimes some elevations require your casting place against requiring precast as against casting place. All right. So typically, the methods for doing the precast, you have a yard somewhere not associated with the site or somewhere in the site, and then you will prepare setting up the casting yard, and then production of precast follow these, preparing the molds, the shape that it is, and then do all the shuttering and assembling process, and then you do your pre-stress and pre-stressing cables inside your uh, cast in place so that lifting will become easier as you proceed. So you're going to be doing the stacking of precast, as you can see from there, and then you will transport them as and when it is cured enough to site as you need it. So before you get to site, you need those hoists and all those equipment to be able to help erect those precast to different height as it is, yeah. So very important method. If you're a superintendent, you need these directions to be able to prepare a foreman's plan to guide them as how these precasts are going to be prepared till it get to site for erection, right? Now, think about the tilt up. This one, you will have the site right there at your at by where the project is, so you can do your tilt construction here. You cast all the slab somewhere on the site, make it cure, and then put it in place. So you will do the tilt right there on the site, right? So the main advantage of the tilt as compared to cast in place is saving the formwork material. If you have a project like a dealership or warehouse or data center, you don't want to prepare huge formworks and all that. You do a tilt concrete and then lift it in place with the help of your crane and hoist as against building a huge formwork for this project, right? So this is a typical process or method of construction. You lay and set up a custom bed and you pour previously slab on grade. Again, form the individual panels, prepare the surface, and then follow this method, right? Very important. I'll touch base with this a little bit. This is when you're pouring concrete under water, right? So placing concrete underwater has a different process. You have the bentonite, and then we have a slam, which talks about the trimming pour process. It starts with your bentonite system here, creating like a case and drive it down to the stratum, and they put the funnel and plug in here in the middle. This is where the concrete is going to go. So as you pour, you lift it up, right? As you lift, as you can see here, the concrete is taking shape and take away those spaces until you have it to the level that you want, and then it will dry in there. And the length of the trimming pipe in the concrete surface as you go have the inflow, and then you have it up to that point, and it's you pull the funnel out, and it becomes the concrete well setting under the water for you. So that is a typical process here under water placement of concrete using your trimming method. I talked about that. It starts like that, right? You put your funnel here, we've cut in all the water from here. And then you're going to be using, as you pull the funnel concrete go through, you put it up. Finally, you get the concrete filled, uh, uniform, and then removal of the head until that is secured. Again, you have another type placing of concrete using the seal gated trimming. The same process. You have your shell created, and then you put your funnel and the pump in there, and then you pulling that as the concrete goes in, and then till you get to that point. You have again another type is using the pump, right? So the pump here, instead of the funnel, it pumps through the concrete all the into that until you get to that point. So this is mostly for bridge project, sometimes over the water. You need to use this method to be able to get your concrete columns placed well enough. If you're using the a pile concrete, so driven pile also so another type that if you're using a precast for that, you can do it. Right. Let's look at the pavement method of construction, right? This is a typical pavement, right? You need to set your traffic controls and direct traffic, as you can see here. The new pavement is coming here on the road surface, and then traffic is directed on the other side, as you can see. And then you need to make sure you have these surfaces, right? Subgrade, very clean. So clear all debris from there before you start pouring. Fabricate and place your reinforcement into these slabs before you you deliver and then pour the concrete in front of the pit, right? Let's go back. Let me go back. Yeah. Again, construct that and then follow those processes until you have your paved concrete really cured before you strike the forms out. All right. Let's deal with a little bit of self-consolidated concrete. All right. This is very important. It's highly flowable kind of liquid, so you kind of pour it, and then it's self-consolidate as it fulls right here and all that. So that's a basic process. As you can see here, this is a typical self-consolidated concrete. As you pour, it fills the spaces. So if it is full, it compact itself over there. So you measure and make sure you have all the level and so on. All right. Another method of your concrete is shotcrete concrete, which is wet mix. You can have your rebar form, and then you kind of spray that wet concrete, I mean, through the hose, as you can see here. And then as it fills all the spaces, and then it's very strong with this type. It give you that strength that we require. And then you have another one that is gunite concrete, which is a dry mix, the same thing. You dry mix your concrete, you spray the gunite, and then um, the dry concrete is conveyed through the hose, as you can see there. So simple process. Most project you require in the selling spaces to be able to conduct that, and your specification will detail which part of the project require a wet spray or a dry mixed spray. All right. So getting to the end of it, we'll look at typically when you are working in the hot weather, for instance, around this time, June, July in Florida or Arizona, it is hard to pour concrete. What do you do so that you don't get your concrete over hardened and brings those cracks that you may not need in the project? So you go through this process. You wet down the aggregate or the cement sand that you need. You wet it using a cold water or inject some liquid or nitrogen into the concrete to cool down the temperature. And then you use, again, the cooling tubes to be able to cool down the concrete. Why do we need to do this? Because if we allow that heat that are in Arizona around this time and Florida, your concrete, instead of 21 days cure, it might take like 3 days. And because it dries fast, it brings a lot of cracks and shrinkage. So you need to cool it down to kind of settle or cure normal for you, right? So you're going to go through those process as mentioned here. Use more resources to speed up the placement. Okay, when you bring the batch plan, you need to have some time within a short period of time to place the concrete as soon as possible. Other than that, it may harden or settle in those drums, right? So very important. If you're supervising a project in those areas around this time, you need to follow this process to make sure your concrete are cool and get the required quality mix that it desire. All right. Think about the cold weather. If you're working in the Midwest region around December, January, February, thereabout, you also have to prepare for your concrete in the cold weather, right? Preparation to during the cold weather, you need to preheat one or more of your ingredient, the water, the aggregate. Other than that, it will sit there for ages. It will not cure for you, right? So preheat before you cure you pour that concrete. Other than that, you're going to be having issues with the mix. So follow those process, pouring in press, and then curing tips and so on. This will help you be able to sorry, be able to get the required quality that you have. So seven, this will give you idea on what to make sure the cure concrete for the time period recommended. Your specification determine which type of concrete in there and how long you should allow for cure. So you're going to be following the tips to make 7 days, 10 days, 21 days, 3 days, and 14 days, and so on. All right. So with this, I'm going to end this here. Go through with your slides on Canvas, and then there will be quiz on this. I'm going to post again the specification and the plan exercises we do in class. So follow this discussion and spot all the concrete element of work that are found in those drawings and specifications that you'll be working with in the group for this week exercise in my absence in class. Thank you very much, and I'll see you next week.